Hello everybody and welcome to the SteelTrace booth at the 5th annual blockchain conference. My name is Tom Meulendijks and I'm the founder and CEO of SteelTrace, and today I would like to show you what SteelTrace does with blockchain in oil and gas. So for today's agenda, I'll be introducing the company, our founding story, and how we got the idea for SteelTrace. Then I'll be going through the key features of the product, and in the end I will walk you through all the higher level benefits that our product has for the industry. So SteelTrace was founded in 2017. I got the idea for SteelTrace while I was working for a pressure vessel manufacturer right near where I live here. I'm a software engineer by trade, and they asked me to look at their processes around material management, how to handle the material certificates. And there I noticed a couple of issues with the current way of working. One, everything was on paper or PDF. So everything had to be manually verified. Norms and specifications to which these products need to comply are written in books and documents, and humans need to make the connection between what is on a material certificate and what has to be on the material certificate. The other problem that I saw was that they were constantly complaining that they didn't trust the certificates, that they came across fake materials. And thirdly, all the data that they got from their suppliers was in an unstructured, dirty format, so it's very difficult to later reuse that data. And thinking as a software engineer, I thought, hey, I might be able to solve this by building a platform where all these companies in the supply chain work together in one process instead of having silos of information and exchanging information through PDF documents. Because what is on these PDF documents and what has to be on those PDF documents are usually numbers, and they need to fall within a certain range. And by storing that information in structured format, you can have a computer do those checks. So here's an example of the supply chain. This is an example of a welded tube. So it starts with a plate. When the plate is made, there are certain tests done. There's a chemical analysis, the tensile strengths, etc. is determined, and then that information is transferred to the pipe mill. The pipe mill then checks if it complies with their specifications and starts to turn this plate into a pipe. And then they start to do tests on this pipe with external laboratories, and in case of a 3.2 material, there can be an inspector present. There can also be an inspector for the customer present to co-sign these documents. And then they gather all those documents, aggregate them into one PDF, and send them on to the stockist, for example. And the stockist has specifications that are based on a range of specifications of their customers. So they'll buy a batch of pipes that they can sell to multiple customers. So they have very stringent specifications with which the pipe mill has to comply. And when they sell it on, there is it can go to an operator directly or to the EPC. And there are specifications there with which the pipe has to comply with. So they also manually verify if the pipe complies. If the pipe then gets cut in half, there's an inspector there to see if the marking on the pipe is written over correctly. So they also have to co-sign documents like with a remarking procedure. So there's all this information flowing back and forth. There are specifications, there is certificates that show that there's a compliance with the specifications. There are people that have to endorse that information, so the laboratory person or the QA person or the inspector. And all that happens on paper now. So that's emails going up and down. So if you take the example at the pipe mill, they'll invite a lab to perform a test. They'll send a sample. The lab will execute the test. There's an inspector present. He'll witness the test, write down the same numbers that the lab writes down. Then the lab starts creating a report maybe a day later, emails that to the inspector, and then the inspector can verify with what he wrote down during his inspection. And then that will be emailed to the pipe mill. This can take weeks. In SteelTrace, we do that a bit differently. We don't use any form of documents. We created interfaces for all these data types that labs and inspectors and mills can enter the data directly in the platform, and they can sign off on it digitally, instantly and in real time. So an inspector doesn't need to write down his own version of the truth. He can be at the lab fills it in SteelTrace instantly, signs it, and then the inspector instantly signs it as well. And then that data gets fed in real time to the pipe mill, who then in their turn can feed that data in real time to their customer. In the previous slide, I talked about the endorsement that inspectors, quality managers, and laboratory personnel have to do on the data that they enter or witness. And on that app is a cryptographic key that is associated with the person, digital identity. And when they're onboarded, the key is generated on their phone. It's not stored somewhere centrally, so it's only available on the person's phone. So there's no central database that you could hack to steal these identities. And the rights of these keys can be revoked. So if a person loses his phone, they can regenerate a new key and revoke the rights on the old one and create the rights on the new one. So whenever they have to endorse a piece of the information, they get presented with a QR code and they scan that with the phone, put in a 5-digit key, and it unlocks the signature and the signing process is initiated. And we don't do that only in the material traceability part, we also do that with onboarding users. So when we onboard a company, they have an admin account and they give users the right to sign. All of that is recorded. So when a user gets signing rights, when signatures are placed, when labs are invited to provide a test result, when they endorse the test result, it's all stored, and it's all stored irrefutably in time. So mathematical proofs of the data are stored, but you always know who put in what part of the information at what point in time. And this way you can get compliance by design. We put all the rules in and people cannot continue without complying with those rules, and everything is traceable. So how does that work then in the material certification part? On one hand, we need to digitalize the specifications. We have an extensive norm database, but on top of that, the customer QCP, ITP requirements need to be entered. And then the supplier can start entering the data during the production process. Everything is instantly validated against the customer specification and the international norms. They can then secure that data by placing their digital signature, and the customer can then do a 100% automated check of all the information that comes in. The new versus the old. On the left side you see a certificate and you see all the red pen stripes. That means the human has verified all this information. In SteelTrace, when the certificate was created, it was already verified against the specifications. So there's no need to do these controls, and as long as everything's green and acceptable in the certificate, you know it complies with the predefined values. And here you can see how a report, in this case a tensile test, is made in the laboratory. And they can load in on top of the international norm specific QCP requirements, and then you can see, hey, the QCP is actually more stringent, so that value does not comply. But if I put in the actual values, it will comply. You can also see that the QCP has asked some additional information here, so that needs to be there before it's acceptable. We have a norm database that is pretty full already and expanding. So all these requirements, what companies need to fill in, which tests they need to perform, what the tests need to comply with. And we already have pre-made databases. So when a lab enters the data, it's all pre-checked. And of course, the capability of adding exceptions. So for example, the specimen size can influence in an impact test what the actual values need to be, and you can set them deviate from the norm. All of this is visible and traceable, so you can always see if somebody made a deviation from the norm based on a customer specific requirement. But what about items that are not produced specifically for the end owner, but it's produced on a stock item basis? So it just complies with the norm or what it thinks that the market needs, but when it comes in to your premises, you want to check if it complies with your specifications. For that, we have a digital rule set creator, and that allows you to create your specifications in a digital rule set that you can then overlay on every certificate that comes in. Every test circumstance, every test result, you can create a rule for. So you can, for example, check, was the impact test done on the right temperature? Was the carbon value what I specified, etc. And then when you overlay it on a certificate, the rules are applied and they'll give you a result whether it's passed or not passed. And if the thing is red, you can act accordingly, but hopefully everything is green and you wouldn't even need to open that certificate at all. Then in order to keep supply chain provenance, there's one important factor. Instead of creating documents and sending them around the supply chain, documents that are copyable, we create certificates with a quantity, and those quantities are set by the manufacturer. So the manufacturer determines how much of their products are in the supply chain. And by doing that, when they transfer it to a customer, they transfer the ownership of X amounts of products. So let's say we're talking about fittings. I'm creating 1,000 fittings. I'm creating a certificate with the quantity 1,000, transferring that to the stockist. When the stockist then transfers a part of that batch to the customer, it needs to split the certificate. So let's say it sells 5, it will split the certificate into 995 and 5. Then it'll transfer the ownership of those 5 fittings. And this way, you ensure that there can never be more products put into the supply chain that came from the original manufacturer. And then what an end owner needs to do, it needs to demand for each product that is sold to them, show me that you are also the owner of the digital counterpart of this product. If they cannot show that, they did not get it from a qualified manufacturer. And this is how you can increase supply chain provenance. So let's go over the benefits. Obviously, safety. Safety is an extremely important topic. You want your personnel to be safe. You want the environment to be safe by having better compliance and providing inspectors with more time to spend on the actual floor of the manufacturer instead of document review, which we automate away completely. You increase the safety, you reduce the human error factor, which eventually should lead to better compliant products. And obviously, if provenance is improved, fake products are reduced, that also should hugely impact the safety. Now we have all that data coming from the supplier in structured data format. And that means that you can later do stuff with that data. You can store it and you can do analysis on it. You can filter it, you can do all kinds of stuff with it. And instead of everything ending up in a C container full of paper, it will always be in a structured data format that is searchable. You can always retrieve the information that you want and combine information on multiple topics. And that leads to data-driven insights. So information that you can use in predictive maintenance. The better you know what the product is made of, the better you can predict what deterioration over time will be. And that impacts when you need to do maintenance, but also if you want to do a life extension study. What do I need to replace? What can I keep? How long will these parts last? But also supplier capability analysis, where you need this type of material. Do we have a supplier that has met these criteria before? Or when they're saying to us, hey, this is really difficult, but you can actually see in the past data that they always delivered it in that format. So, or always delivered it according to the specs already, they just don't want to guarantee it. This can all help end owners make better decisions. Data archiving and traceability, I already mentioned it before. The archiving is really important, but also the fact that you can find it back, and you can always find back who took responsibility for that specific impact test on that product 10 years ago. And this can be extremely valuable with root cause analysis to really find out what went wrong here. But it also goes for all the manufacturers and everybody in the supply chain. By working in SteelTrace, we automatically archive everything they do. So there's always traceability. You don't need to worry that they need to have their administration on order, because it happens automatically. And data storage is one thing, data retrieval is another. So right now you have things in paper boxes. If you want to do life extension studies, if you want to understand what your assets are, if you want to value your assets, you're going to sell your assets and you want to show how valuable they are to the buyer. It's extremely difficult to retrieve that information right now because it's in dirty format. With SteelTrace, you can make data aggregations. It's searchable, it's filterable, it's presentable in multiple formats. So all these aspects should improve. Moving from compliance by audit to compliance by design. So instead of having to check all the information that comes in, you predefine the rules. And then you reduce the need for control. Actually, everything is controlled automatically during the process. So our system is also aiming to not certify at the end of a production process, but to certify each individual step during the process. Doing a test, sign off on it. Doing an analysis, sign off on it. Doing a heat treatment, sign off on it. And all that information is automatically verified against the QCP requirements. That information, if you certify during the supply chain, that also means that information can be made available in real time to the customer. You can much more early detect non-conformities. So The risk to projects is significantly reduced. You know if things going to be on time, you know that they are first time right. So the risk of getting some stuff delivered to your site that isn't ready, that isn't correct, so you have to send everybody home again, is greatly reduced. Time reduction, gathering all those documents, aggregating them into manufacturing record books, etc. Lots of this is going away. All the stamping, signing, everybody that has to endorse it, you remove a lot of the need of this. And gathering the signatures, it can save so much time, and that can make the difference between being on time or being too late. And being too late is costing money. If your boat is about to go out because they're going to lay that offshore pipe, but you find out that there is some stuff missing, you just don't have an overview. Or you have to keep people constantly creating overviews. But if you predefine the rules in steel trays and people start producing, those overviews can be automatically generated, and you can predict better when things will be done. And not being able to send a boat out because the products aren't good, that's just a waste of a lot of money. Supplier performance. How have they performed in the past? What have they delivered to you in the past? This is all information you need data for to make those decisions. And with the data we capture, it can help improve decision making from a sourcing perspective. It could even in the future be, find me the best supplier that always meets these criteria, and we'll connect you to that supplier. Those are our future possibilities when you have all this information about your supply chain. Also efficiency. Companies now all do their own thing. They all have their own process of certification. Some are efficient, some are completely inefficient. But a survey done with the pilot customers that we had, we could save them up to 3 hours to certify material. And because it's done in real time, it doesn't happen after the fact. So you don't have pipes waiting in the yard, waiting to be certified so that they can go out. Certification should be done when the pipes are ready and done. Physically inspected, they should be able to go out. So also your suppliers should be more efficient. Insurance cost. Imagine you're going to insure your chemical factory or your petrochemical installation. The insurer has a choice. Either I have a container full of paper documents that I hope are real and I hope have all been verified correctly, or I have a structured database of which I can always have everything traceable, do analysis on. At any point in time in the future, I can retrieve information with the blink of an eye, find out who did what when. The risk profile should change. And we think that it eventually will reduce the cost of insurance premiums. Regulatory agencies. Now, there is a past, and in that past, there were things built that had not been documented well enough. So there are pipelines out there that we don't know what is actually in there. And this has caused regulatory agencies to put pressure on end owners to say, hey guys, you need to do due diligence on all your assets. And Steel Trace is a huge opportunity to show that for each new project, you'll have way better control and way better archiving and way better knowledge on what your assets actually are. And then you can move ahead of potential new regulation that'll force bureaucracy on the process to force companies to do their due diligence. So this can really be one of those weapons in the hand when negotiating with regulatory agencies. Like, look, we're working on this. We have a system that'll give us full control over the supply chain. Everything you need to know we'll have in databases. So we got you covered. Last but not least, imagine that all these savings also impact the carbon footprint. You'll have a paperless office, all that redundant printing, signing, stamping, scanning, printing, signing, stamping. The amount of trees that we can save is gigantic. Better able to recycle or reuse products, have less product returns, less delays, where, delays are costly, but they also impact the carbon footprint, and hopefully also will have an incident reduction together. And these are all things that you can calculate in your carbon footprint. And one of the future goals of Steel Trace is also to add the carbon footprint to the certificate of each company that has worked on it. So you'll be able to identify, okay, this pipe versus that pipe, what is the carbon footprint of production? Because it could be that, for example, there's a huge distance between the factory and as a stockist, and there was a lot of energy used to transport that. All those things in the future will be recorded and will help you also decide which pipe you will buy and reduce your carbon footprint. And the end goal is cradle to grave traceability. You want to also do inspections on pipes, see how far they degraded, and add that to the record of the past, and eventually have a full record, 100% traceability of all your assets during the full life cycle. Even when you're taking it out of commission and you're selling the steel for scrap, you can record that, hey, it was now sold for scrap. This is no longer in use. This is no longer a valid pipe. So let's say you sell it to a scrap maker and he decides to sell it on the market because the pipe still look good. You can always prove that you took that pipe out of commission and you sold it. Thank you very much for watching, everybody. We are available at our digital booth. Feel free to start a Zoom call with us, and we're happy to answer any questions you may have. If you're interested in steel trays and want to connect at a later time, you can always go to our website for more information, steeltrays.co. And we also do a weekly product demo on Thursdays. For that, you can sign up at steeltrays.co/weekly. On odd weeks, we do it Houston time, 9 a.m. And on even weeks, we do it Singapore time, 3 o'clock in the afternoon. Thanks again, and hope to speak to you soon.